Algebra 1, Semester 2, it's the third unit called Quadratics. It's the 10th lesson, Using Intercept Form Practice. It's on creatormath.com or creatormath.weebly.com under the Algebra 1 tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So get the notes off the table of contents, put those on the right pages in the comp book. So this says use desmos.com. Using desmos.com, find the zeros of the following. So this is just zeros practice or roots. Remember, to find roots, all we need to do is replace y equal to 0. That would give us 0, in this case, x plus 4 times x squared minus 25, right? The 0 multiplication rule says that if for something to equal 0, either this has to be 0 or that has to be 0 or both. So we take all those options and plug them in. So for this x plus 4 to be 0, we would just take x plus 4 and put it equal to 0 and solve. Subtract 4 from both sides. One of your options is minus 4. So here's a minus 4. This one doesn't have a minus 4. It's out. But this one does. Let's look at this. This is still not factored yet. This is x squared minus 25. Go back to that lesson on factoring. This is one of the special products where the middle term has canceled out. So I know from that prior lesson, I know that this is x plus 5 times x minus 5. Right? I know that because when I multiply x plus 5, x 5 times x and then negative 5 times x, those cancel out and that middle term disappears, and 5 times negative 5 is minus 25. So this is going to give me a root of x equal to 5, or equal to minus 5 on this one, and x equal to plus 5 on this one. Those are the actual roots. So I got 4 roots. Negative 4, negative 5, positive 5. Same instructions. It looks like we have to factor it. It looks like there's a negative going on in here. I'd probably multiply through by negative 1 and get rid of that. I wonder if I can do that. That would make this x squared minus 12x plus 35. Can I do that? What if I have an x minus 5, x minus 7? Now we're going to do FOIL. And this is all, you guys, I'm going fast on this because this is a prior lesson, right? Go back and look at this lesson on how to factor trinomials and quadratics. And let's do FOIL. X times x is x squared. A negative 5x and a negative 7x is negative 12x. And a negative 5 times a negative 7 is a positive 35. So when you put each of these, and this is all equal to 0, so we can find the roots, right? We're making this 0 here. And so we have to take x minus 5, put it equal to 0, so we're going to get x equals a positive 5. This is going to get x equals a positive 7. So I'm going to come over here and say 5 and 7. Those are my two roots. I'm going to, anytime I see a negative up front, I'm going to multiply through by negative 1. I'm going to get 0 equals x squared minus 14x plus 40. What two numbers when multiplied together? Yeah, I'm cheating a little. I'm looking over here and I'm seeing a 4 and a 10. And I do know that a 4 and a 10 add to 14, and a 4 times a 10 multiply to 40. And that's the rule for factoring. So I'm going to get a x minus 4 times an x minus 10. That would give me a positive 40 on the tail, and it would add to be a negative 14x. So I'm good with that. That makes the roots here x equal to 4 and x equal to 10. 4 and 10. F of x equals 3/4 times this. Woo. I'm going to ignore this altogether because I like my binomials factored. I need the binomials in the lowest form, right? So this gives you a root of x equals to minus 10 and a root x equals to 6. By now you know they just reverse, and I could put them equal to 0 and solve, or just know they equal that. Oh, sorry guys. I should make it so you can see it. Okay, let's go back through what I was saying. I would ignore this fraction because it's just going to be 0 out front. These two binomials are reduced to their lowest level, so I'm happy about that. The x plus 10 just turns into a root of x equal to minus 10, and the x minus 6 turns into a root of x equal to 6. So I have a negative 10 and a 6. So this has got a negative out front. I don't know if I like that either, but let's see what we get. This would give us x equal to a minus 2 would be the actual root. This would give us x equal to a positive 6. So I have a 6 and a minus. I like this here. Basically speaking, maybe the easiest way to think of this negative out front is like being anything multiplied by a negative 1. I'm not sure I have a good explanation for that, other than it makes the parabola open upside down. So say you did have, let's do a rough parabola, right? Say there's a negative 2 here, that's a root, and there's a positive 6 out here. And normally the parabola would go something like this, neglecting any idea of where that vertex is. I don't know, I'm just going to draw it like this. But once we have this negative out front, it flips us upside down. So now this thing goes like this. And that's its effect, and I'm going to ignore it for anything else. It doesn't shift where the roots are, whether there's a negative out there or not. Maybe that helps to say why we can ignore it, okay? And that factor goes to 0 anyway. All right. So this one's negative also. 1 and a 9, I'm cheating a little. I might multiply by negative again. Let's multiply through negative 1. So we're going to get 0 equals 2x squared minus 20x plus 18. If I have a 2x and an x, right, I'm factoring this. This would be 2x times x is 2x squared. I'm okay with that. I need two numbers that equal 18. Well, I'm going to do 9. Question is where to put the 9. Let's put the 9 here because I want 2 times 9 is 18. And I believe I'm going to have a negative here and a negative here, and I'm a 2 here. All right, let's see what we get. Now let's just do trial and error, right? Inside would be negative 2 times 9 is 18, so a negative 18x. Outside would be a negative 2x. Well, sure enough, negative 18x and negative 2x do add to negative 20, so I'm happy about that. Negative 9 times negative 2 is a positive 18, so I'm happy about that. Now let's do roots. This is going to be x equals 9. Okay, so anything without a 9 in it's out. Then don't forget this one. Let's just write it out. This one's looking a little bit more complicated. Put it equal to 0 and solve, right? That's what I did for all of these. That's what I did here too. I just did it in my mind. This is gone. 2x equals 2. Divide both sides by 2, and x equals 1. Oh. Okay, right here. That one's a little bit tougher, and I don't know why my brain's going a little bit slower on it too. So do the best you can, guys, and follow through. Again, I don't like the negative here, so I'm going to say 0 equals x squared minus 9x plus 14. A 2 and a 7 are 9, so I'm already on track to this thing. X minus 2, x minus 7. The negative 2 times the negative 7 is a positive 14. Check. Negative 2x and the negative 7x are minus 9x when combined. Check. So I'm good with this. This is going to be a root of x equal to 2 and x equal to 7. Another negative. 0 equals, let's do 3x squared minus 9x plus 6. Let's reverse them all. That's what you do when you multiply through by negative 1. Doesn't affect anything if it's a 0 here. We need a negative in the middle. We need probably a 2 and a 3. One of these has to be a 3x, one's an x. I wonder if this is negative and this is negative. And we had a 2 and a 3. 6. Let's put the 3 here and the 2 here. Okay, so let's do FOIL. First, 3x times x is 3x squared. Check. That works out. Let's do the tail. Negative 3 times negative 2 is positive 6. Check. Do we get a negative 9? Negative 3x and a negative 6x do combine to negative 9x. anytime you have these lead coefficients here, right, and this just becomes a lot more complicated. And there are a little bit more rigorous methods to do it. I guess I just kind of like winging it and figuring out what each one is. It's a little bit challenging for me, and I think it's fun. So now let's do the roots. 3x minus 3 equals 0, right? Plus 3 on both sides. Solve the two-step equation. And 3x equals 3. Divide both sides by 3. And x equals 1. So I already see the 1 here. This one is just going to be x equal to a positive 2, 1 and 2. Well, I guess they're getting us to practice this shift it, because I see another negative. 0 equals x squared minus 7x plus 10. I think it's an x. I think it's an x minus 3. Oh, how about 2 and 5? X minus 2, x minus 5. All right, so negative 2 times negative 5 is positive 10. X times x is x squared. And a negative 2x plus a negative 5x is negative 7x. So this is going to be x equal to 2 as a root, and this is going to be x equal to 5 as a root, 2 and 5. All right, one more. Let's do 0 equals 2x squared minus 16x plus 14. We know we're going to have a 2x somewhere in here and an x, because x times 2x is 2x squared. We might have minuses in here. Not totally sure about that, but let's see what happens. How about a 2 times 7 is 14? And I kind of would like the 2 here and the 7 here. And I'm already thinking in my mind, negative 7 times negative 2x is negative 14x, and negative 2x in that does combine to negative 16x. So in my brain, I'm trying to check these different things. 2x times x squared is 2x squared, check. Negative 2 times negative 14 is negative 2 times negative 7 is positive 14, check. Negative 2x plus a negative 14x is negative 16x. This is it. So 2x minus 2 equals 0 plus 2 plus 2. 2x equals 2 divided by 2 divided by 2. X equals 1. And this one just changes to x equal 7. 7 and 1. So this is Algebra 1, Semester 2. It's the third unit called Quadratics. It's the 10th lesson in this unit so far, and it's called Using Intercept Form Practice. So this is intercept form that we're working on, and we're using it to find roots. Find it on creatormath.com. Make sure you're under the Algebra tab.